So welcome again. I will still give another example on determination of extremum values for function of two variables. So example. So the example is find the relative maximum find the relative maximum and minimum values of the function f of xy given by xy minus x cubed and then minus y squared. Find the relative maximum and minimum so the function is f of xy equals to x y minus x cubed minus y squared. So we still follow the steps we gave in the previous class. So if you have not watched that video for illustration of the steps, I'll encourage you to watch it before you watch this example. So step one is to find the partial derivatives. So step one, determination of partial derivatives so the partial derivatives we have fx, we have fy, we have fxx, which we call r, and then we have fxy, which we call s, and we have fyy, which we call t. So in our problem, fx or partial f partial x will be given by, so fx, which is partial f partial x, for this function will have y minus 3x squared. And then fxx, or the second derivative of this function with respect to x, partial squared f partial x squared. So we differentiate this one with respect to, and this is what we are calling r, we'll have minus 6x. And then fy will be, this will give us x minus, so this is y squared, so it'll be 2y. And then s, which is partial squared f partial x partial y, and this is partial x of partial f partial y will be given by partial x of this function x minus 2y. This is 1. And then fyy, which is partial squared f partial y squared. So differentiate this with respect to y, so we get -2 as our value. So that's step 1 done. Step 2 is now to find the stationary points. So step 2, determination of stationary or critical points. So stationary points A, B. And stationary points are obtained by equating fx to 0 and fy to 0. So these are fx, so say y minus 3 x squared equals to 0, and then we have x minus 2y equals to 0. So we'll solve this system. So call this one equation 1, and then call this one equation 2. So this is equation 1. This is equation 2. So the easiest way to solve this, we can say y is given by 3x squared, this from equation 1. So therefore, replacing this for y in equation 2 will have x minus 2 3x squared equals to 0. And this will be x minus 6 x squared equals to 0. So these are quadratic. We can factorize x into 1 minus 6x equals to 0, which tells us that x equals to 0 or 1 minus 6x equals to 0. This implies x equals to 1 over 6. So there are two values of x equals to 0 and x equals to 1 over 6. So to get the points, we say when x equals to 0, then y will be 3 times 0 squared, which will be 0. So i.e. the point is 0, 0. And then when x equals to 1 over 6, then y will be 3 into 1 over 6 squared. So this gives us, so 3 times 1 over 36 is 1 over 12, i.e. the point is 1 over 6, 1 over 12. So therefore, we have two stationary points or two critical points. So we'll have to test for all of them in order to determine whether the nature of each of the 2 points. So next step, step 3, find RT minus S squared are these critical points. Find RT minus S squared at the stationary points. Remember from our calculation, our R, which is fxx, is a function minus 6x. And then our S, which is fxy, is given by 1. And our T, which is fyy, is given by minus 2. So for the point 0, 0, R at 0, 0 is simply minus 6 times 0, which is 0. And then f xy, or the value of S, when we replace x for 0, y for 0, that's a constant function, so we get the same function. So S at 0, 0 will have still just 1, and T at 0, 0 will still just have negative 2. And then for the point 1 over 6, and then 1 over 12, R at this point will be negative 6, x value replaced by 6. So this will give us negative 1. And then S at 1 over 6, 1 over 12. So because this is just a constant function, it means to be 1. And then T at 1 over 6, 1 over 12. This being a constant function remains to be negative 2. So for the point 0, 0, RT minus S squared will be given by R is 0, T is negative 2, S is 1. So this will be 0 minus 1, which is minus 1, so which is less than 0. So since RT minus S squared is less than 0, then 0, 0 is a saddle point. If you remember the steps we gave out, when this quantity is negative, then we have a saddle point. And actually the value of this saddle point, 0, 0, if you replace with this x by 0, so we'll have 0, 0 minus 0 cubed, and then minus 0 squared. So the value of the function at this saddle point is just 0. And then for the next point, 1 over 6, 1 over 12, RT minus S squared will be R, from our calculation is negative 1. T is 1. And then S is 1. Then square. So we have negative 1 minus 1, which will give us negative 2. Okay, so we have this T is minus 2 not, T is minus 2 not 1. So sorry for that. So T, so we have R for 1 over 6, 1 over 12. According to this calculation, R is negative 1. And then T from this calculation is minus 2. Minus S is 1. and then square. So this will be 2 minus 1 times minus 2 is 2, and then 1 squared is 1. So 2 minus 1 is 1. So this is a positive value. So since RT minus S squared is positive, and the value of R, which is given by, from this calculation, R is -1, so which is negative, then the point 1/6, 1/12 is a maximum, is a relative maximum point. So then now the value of the function at this point, 1/6, 1/12, will be xy, so add 1/6 times 1/12 minus x cubed, 1/6 cubed, and then minus y squared, 1/12 squared. So 6 by 12 is 72. So I have 1/72 minus 6 power 3 is 216 minus 12 squared is 144. So this will give us, so 1/72 minus 1/216 minus 1/144. So 1/432. So this is the maximum value of the function. So hence the relative maximum value of f is 1/432 and occurs at the point 1/6, 1/12, at the point 1/6, 1/12. So that is how we determine the extremum values of that given function. So thank you.